Birds of a feather: how a 1,000-year-old idea became machine learning. Imagine you're in London in 1854. A deadly cholera outbreak is spreading through the streets of Soho. Entire families are dying, and nobody knows why. Most people believe disease spreads through bad air, but one doctor disagrees. His name was John Snow. Instead of accepting popular beliefs, Snow began collecting data. He marked every cholera death on a map and plotted the locations of nearby water pumps. Soon, a pattern emerged. Most of the deaths clustered around a single pump on Broad Street. People living closer to that pump were far more likely to become sick than people living closer to other pumps. This simple observation helped Snow prove that cholera was spread through contaminated water. His investigation saved lives and became one of the greatest achievements in epidemiology. But here's the surprising part. More than 150 years later, computer scientists realized that Snow's map illustrated a mathematical idea that sits at the heart of machine learning. That idea is called the nearest neighbor principle. To understand it, imagine several water pumps spread across a city. For every location in the city, we ask a simple question: which pump is closest? We can divide the city into regions where every point in a region is closest to the same pump. These regions are called Voronoi cells. John Snow unknowingly used this concept when he analyzed the cholera outbreak. Now let's jump back even further in time. Almost 1,000 years ago, an Arab scientist named Ibn al-Haytham, also known as Alhazen, was studying vision and perception. He proposed something remarkable. When we see an object, our minds compare it to similar objects stored in memory. If we see a dog, we recognize it because our brain finds something similar among previous experiences. If we have never seen anything like it before, recognition becomes difficult. This idea sounds surprisingly modern. In fact, it is almost exactly how one of the simplest machine learning algorithms works. The algorithm is called nearest neighbor. Suppose we have many handwritten examples of the digits 2 and 8. Each example is stored as data. Now a new handwritten digit appears. The algorithm compares the new digit with all the examples it has seen before. If the closest example is a 2, it predicts 2. If the closest example is an 8, it predicts 8. That's it. No complicated equations, no deep neural networks. Just find the most similar example and copy its label. This is known as the one nearest neighbor algorithm. But there is a problem. What if the nearest example is wrong? Imagine someone accidentally labels a handwritten 2 as an 8. The algorithm would learn from that mistake and might make incorrect predictions. Machine learning researchers call this overfitting. The model pays too much attention to noise and errors. To solve this problem, scientists developed k-nearest neighbors, or KNN. Instead of looking at only one neighbor, the algorithm looks at several. For example, if k equals 5, it examines the 5 closest examples. Each neighbor gets 1 vote. The majority wins. If 3 neighbors are labeled 2 and 2 are labeled 8, the new digit is classified as a 2. This voting process makes the algorithm much more reliable. Random mistakes have less influence. The decision boundary becomes smoother and better at handling new data. In the 1960s, researchers Thomas Cover and Peter Hart studied the mathematics behind KNN. They discovered something remarkable. As the amount of data grows larger, KNN approaches the performance of the best possible classifier, known as the Bayes optimal classifier. In other words, a surprisingly simple algorithm can become extremely powerful when given enough data. Today, nearest neighbor ideas are everywhere. Recommendation systems use them to suggest movies, books, and products. Image recognition systems use them to identify objects. Pattern recognition systems use them to classify data. Even biological systems may use similar principles when recognizing smells and sensory information. However, KNN has a weakness. It must remember all of its training data. As datasets become enormous, finding the nearest neighbors becomes slow and computationally expensive. And there's another challenge called the curse of dimensionality. As data gains more features and dimensions, points become increasingly spread out. Finding meaningful neighbors becomes harder and harder. Despite these challenges, the nearest neighbor algorithm remains one of the most important ideas in machine learning. Its core principle is beautifully simple. Things that are similar tend to belong together. From Jon Snow's cholera maps to modern artificial intelligence, this idea has transformed how we understand patterns, make predictions, and teach machines to learn. And it all comes down to one timeless observation: birds of a feather flock together.